viewers. This is Mr. Odingo again coming with chemistry. And we want to move from the last lesson we started with, that was matter. And in the previous class I was able to explain what matter is, and I was able to say that we define matter as anything that occupies space and as mass. We went further to look at the three states of matter. Today we want to be able to understand energy. In the three states of matter, we want to compare the changes of energy across solid, liquid, and gas state. Other than kinetic energy, we also have to understand the movement of particles between liquid, solid, and also in gaseous state, and also how the particles are arranged. So viewer, welcome, and any question you have, be sure to subscribe, and also you can post your questions so that we can be able to respond to them in real time. Thank you. And fast forward, we need to be able to explain today what we call changes in energy. In energy, movement, other than movement, we want to look at arrangement, and interparticle spaces and interparticle spaces between particles in the three states of matter, So in this lesson of today, I want to be able to assist you to understand that we are going to study the energy. How do we compare energy, amount of energy in solid state, liquid state, and gaseous state? We are also going to see how do we compare the movement. And in this case, energy is related to movement. Kinetic energy is very much related to movement across the solid state, liquid state, and also gaseous state. Arrangement, we want to study or see how the particles are arranged in solid, liquid, and gaseous state. And finally, we want to see how the spaces, interparticle state, the spaces between particle, solid, liquid, and gas state compare. So again, for me to be able to explain to you the lesson of today, I want to use my three rectangles. I've not drawn them to scale, but I want to invite you to understand that is going to be used for illustration. These boxes, I want to assume they're the same sizes. That's one thing we have to assume before we're able to understand what I want to show. And I want to be able to use my small cycles to represent particles in solid state. This is my solid state. This box will represent the solid state. The second box will represent liquid state. And the third box will represent the gas state. So now as a student, you understand how we filled the boxes in the previous lesson. We were able to show that the solid state, we drew boxes, and these boxes I've drawn, those are 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I want to keep the 20 cycles, 20 small cycles in this box, in this rectangle. These 20 small cycles, they represent particles in any solid. I want to go quickly to show the particles in liquid state, which you already know how to draw. And in this case, I want to show 1, 2, 3, 4, 5, 6. I've shown 6 particles in liquid state. And then in gas state, I want to show 1, 2, 3. I want to show 3 particles in gaseous state. So these particles here, we want to be able to understand how do energy, movement, arrangement of particles, and interparticle space compare across the 3 states, solid, liquid, and gas. And I want to move very quickly to be able to use a table. And this table of mine I want to use a table across the way I've drawn them. This table is going to use these particles here. And this table of mine here, if I go quickly to explain this table, I want to compare the first row, I want to compare energy. And when I talk about energy, I will talk about kinetic energy. Kinetic energy. We want to compare kinetic energy across the three states of matter. And when I come here, in the previous lesson, I tried to illustrate to you the type of movement that we have in solid state. And we said that this movement, the particles here, they vibrate. So if they vibrate, it means they don't have that much power, that much energy. The kinetic energy to make them move a lot is not there. So we say that this one has the lowest kinetic energy. Lowest kinetic energy. Lowest kinetic energy in solid state. They have the lowest kinetic energy. When you move to liquid state, we say the particles are able to move. So I want to use the word high. The word high here is comparative. Or let me use the word low. Low, instead of using lowest, let's use low, high, and then we go for gases, highest. Highest here because particles of gas move very fast. Particles of gas move very fast because they possess a lot of kinetic energy. So we say that when you talk about solid state, the kinetic energy is slow. I want to use that word low to refer to the word small. The kinetic energy is small. When we come to liquid state, the kinetic energy is high. That's why the particles can move, but they don't move that fast as compared to the particles in gaseous state. That is kinetic energy. When I come to movement here, we can talk about two things in movement. Two things about movement we can talk about. Do they move faster? Speed of movement. We can talk about, do they move in a particular order? But let us concentrate in whether they move fast or slow. And movement, I said here, is connected to kinetic energy. If it has more kinetic energy, the movement is fast. If it has less kinetic energy, the movement is slower. So I want to feel solid state. We say they have low kinetic energy. These particles here simply vibrate. They don't move from one point to another. So we can talk about the kind of movement that the solid states exhibit is vibration. They vibrate at fixed position. Let me add that. Vibrate at fixed position. They vibrate at fixed position because they don't have spaces to move. So they just vibrate where they are. When you look at the liquid state here, the movement is slow. Movement is slow. So they move from one point to another, but movement is slow. Slowly, move slowly. Let me use that. Move slowly. Move slowly. Slowly from one point to another. They move slowly from one point to another. If I move to the gas state here, I believe this one, you know the answer. The point is that the gas particles move fastest, let me say so. Across the three states of matter, movement here is fastest. Move fastest from one point to another. The movement is fastest. They move the fastest from one point to another. And then the third point you're supposed to talk about is arrangement. Arrangement here. Arrangement here, we have to understand how the particles are arranged. Are they arranged randomly or they are arranged regularly? So one thing we have to know and understand in this liquid state here is that they are arranged regularly. So their arrangement here is regularly arranged. What does this word mean? It means that there is kind of a pattern. There's a pattern. You can see that we have one row, second row, third row, fourth row, this one, first column, second column, this one. They are arranged in a row. We can actually count easily by saying that this is 1, 2, 3, 4. 1, 2, 3, 4, 5. 4 times 5, there are 20 particles in this solid state here. We can count that easily because these particles are regularly arranged. When we come to the liquid state, these liquid particles, we can talk about of them that they are not particularly rearranged. Let me go to gas first. Let me talk about gas. It's not regularly arranged completely. So we can also talk about randomly arranged. So the particles in gas state are randomly arranged. These ones are regularly arranged. Then liquid state, it means it is somewhere in the middle. But we can always say that they are also randomly arranged. Now we can compare the one, this is less randomly arranged, this is much more randomly arranged. Why can we not say? Someone can ask that, Mr. Odingo, these particles are also existing in rows and columns. But remember I said that these particles will keep on moving, changing position from 1 second to another. 1 microsecond to another, the particle is moving. So you cannot be able to determine the pattern at one particular point. If they are regular now, in the next second they will not be regular. So we can also talk about this one here, that they are randomly arranged. But now we know that gases are more randomly arranged than liquid state. Let me say more random, because the movement of gases is very, very fast. So you cannot be able to determine the order even in one particular second. So these things are random because they keep on moving. Something that keeps on moving keeps on changing the arrangement. So you can never locate and determine that is it regular now, is it not regular now. That particular point is very hard to be able to determine. The last one, which I want to talk about, is spaces. Spaces between particles. Spaces between particles. Now the spaces between particles, no space between solid particles. No spaces, we can see, no spaces. The particles have no space whatsoever, they cannot move. So there are no spaces in the solid state. But here we can say small spaces. Small spaces in liquid state. Small spaces, they space but it's small between the liquid particles. And then in gas particles we say that there are wide spaces. Wider spaces between the substances in liquid and gaseous state. So these things, they will come in examination and will be required to be able to understand what happens in energy, in movement, arrangement, and spaces between particles as you move from solid state to gaseous state across the liquid state. Viewers, that will mark the end of our lesson today, and tune in for the next class.